So, Stat, ready to talk about time value of money?
I'm ready.
Okay, time value of money. If you're really bored with your life, you can go look this up. I've actually talked about time value of money on social media.
Wow.
Don't be that impressed, Stat.
I'm not. I was being polite.
Okay, so Stat and I will help you work through time value of money. So I got a question for you, Stat. Would you rather have $1,000 today or $1,000 in 1 year?
Today, why would I want to wait?
Good point. Why would you want to wait at all when you can have it now? How about $1,000 today versus $2,000 in a year?
2,000? Oh, wait.
That makes sense also. It's a lot more money, so you would want to wait. What about for $5? Now would you wait?
Not $5. I want the money now.
So the problem is this and this are not equal. You clearly have a preference for this one.
Absolutely. Who wouldn't want it now?
Well, that's pretty much true. We'd all want it now. So the question becomes, what would that have to be for you to say they're equal? And it partly depends, of course, on an interest rate. Let's go with the 8.5% that was actually in the problem.
Okay, now you got numbers. You're starting to kind of lose me.
Well, let's do some calculations. If you're putting money in the bank, so you started, so today you had $1,000, and you put money in the bank and a bank CD for 1 year for 8.5%. This calculation's not terribly difficult. Oops. I'm going to put the exponent on there, it's just 1, just to see the full formula. So that makes sense. So $1,000 today at 8.5% is going to give you $1,085 in the future. So if this is your personal kind of internal rate, actually these are equally good to you. There's no winner here. You're indifferent. And that's how the calculations from a current to a future value is done. But let's flip it around. What if instead you have $1,000 a year from now, same interest rate, and I say, what would you give me today to have $1,000 in a year?
That looks a little harder. I could do the first one in my head, I think. I can't figure this one out.
You're right, it is a little bit harder. But look at how we did it up here.
Multiplication.
Yep, multiplication. So if we went from present to future with multiplication, now we want to go from future to present.
Divide?
Good guess, Stat. So the present value of $1,000 a year from now is the $1,000 divided by or 108.5%. Ooh, that's an ugly looking number, so let's make it format-wise a little nicer. So at 8.5%, those would be equal.
I kind of get it, I think.
So $1,000 a year from today is worth $921.66 today if your rate is 8.5%. And the bigger this rate is, just like here, you'd make more money if you had a bigger rate. If you're getting 15% on your money, it would take more money in the future to make those equal. If you're getting 15%, $1,000 in the future is not worth as much today as it'd be worth at 8.5%. If you have very, very small percents, there isn't much difference. Just like you wouldn't earn very much money, you wouldn't make much of a difference here. So the interest rate is key. The idea, though, still is always the same. That I'll go back to just 8% just to make it easy. Money then is worth a different amount than money today. $1 a year from now is worth less than $1 today. $2,000 a year from now is worth less than $2,000 today. What do you think? Making sense, Stat?
Yeah, kind of. My brain kind of hurts, but it's kind of making sense.
Well, let's look at then how to actually calculate this in a different setting. I've bolded over here the interest rate because it's so important. So how would I compute the net present value of this deal? 18 months of payments, $500 per month, 5% annual rate. The nominal value is $9,000, 18 times 500. But we know it's not worth $9,000 because it's not today. It's coming in the future. Well, there's 3 ways in Excel to find the present value of this kind of future cash flow. You can do the manual calculation that we just did here on a monthly basis. It's not that hard. So $500 a month from now at 5% interest has a present value 1 month from now of $476. Not 5%. I got to do the monthly. Not that number looked awfully different to me. There we go. That makes more sense. At a 5% annual rate, if I'm doing it by month, monthly rate 4.2%. $500 at the end of the month is worth $497.93 today. $500 12 months from now is worth $475.66 today. $500 18 months from now is worth $463.94 today. So this nominal $9,000 cash flow, when it's done this way, actually has a net present value of $8,653.43. It doesn't have a value of $9,000 because you're not getting all of it now. So this is kind of why I put it here, the hard way. You can actually compute the net present value for each month and add them all up. There's an NPV function. And I say this is still the hard way for this example, but I'll show it to you. It's literally the NPV function. It says, what's your rate? We're still going to use the monthly rate because this is on a monthly basis. And where are your cash flow values? Well, you just grab the string of values. And this function, I may have a little note here on the side, this function assumes that it's an end of period, which is why we took the first month payment, and even that had a lower value because it would not be till the end of the month. You'll notice we do get the same value. Now there's also a present value function in Excel that doesn't require you to lay things out like this. Present value says what's your rate, what's your number of periods, and what is your payment. Now we had this problem with payment functions as the cash flow is going 2 different directions, that way and this way. So I'm going to make this negative so everything comes out positive. And it's got the future value and type. The future value is 0. The type we're assuming end of the month. So again, I have 3 different ways to get it. Why do I prefer this method? I don't have to make any of these tables. All I need to know are the numbers over here for this particular approach. So why do the other ones exist? Well, the manual one, it's just algebra, you can do it. So why net present value? Well, what if I didn't have the exact same value per month? Let's go way over here. What if I had something like this, where I'm doing it by years now, just for whatever reason. I had years or months, and the cash flows were different every month. Then the PV function wouldn't work. For this one, the net present value, I'd hate to have to use the net present value function. I'm doing an annual, so we'll make it a 5% annual rate. And here's my string of values. So the net present value of these 5-year cash flows is $51,216, where the nominal value, you just sum them up. But it's not really worth $60,000 because you don't get it all today. You get it over time. And that's where the net present, when the cash flows differ, the net present value function is really pretty handy. But if the cash flows are fixed, the present value function is actually a whole lot better. So that's how time value of money works. That was a long 10-minute detour, but now we will get back to our specific auto leasing problem.